Hello, we are Ecofam, and we will present you the industrial process of brewing production. Beer is considered to be a fermented aqueous drink. Its elaboration is very popular since 1500 BC. The Egyptians were the first ones to document this process on papyrus scrolls, but it is also said that this brewing process dates back to the cultures of Mesopotamia. Then, beer followed a route from the Middle East up to Europe, where it became extremely important for its nutritional value and because it was safer to drink beer than water. The modern beer was born since the Middle Ages by the monks, but the recipe has been modified a little bit due to the existence of different cultures and countries that have specific preferences. This is why nowadays we have many types of beer. The brewing process is based on the use of starch, a carbohydrate obtained from agricultural raw materials and flavored by hops. It provides aroma and bitterness to this beverage. Its composition also includes water, yeast, and barley malt. This barley is composed of many ingredients, such as corn, rice, or wheat. The global beer market was valued at approximately $530 billion in 2016 and expected to reach approximately $750 billion by 2022, growing at a compound annual growth rate of around 6% between 2017 and 2022. Moreover, other businesses depend on the beer industry such as agriculture, packaging manufacturers, equipment manufacturers, marketing and advertising businesses, shipping companies, and many others. In the last 2 years, Mexico has become one of the main producers of beer worldwide. In 2016, it occupied the 4th position, below China, United States, and Brazil. According to Cerveceros de México, the country is the 6th consumer of beer worldwide, as it counts with approximately 63 million of beer consumers, drinking between 60 to 62 liters per year. Brewing is a great source of employment, providing 56,000 direct jobs, 2.5 million indirect, and 3,500 in agriculture. Additionally, it represents 4% of the total tax collection in the country. Since ancient times and to this day, alcohol is regarded as a social leveler. Why? Because drinking facilitates social bonding, thus uniting people from different backgrounds. Nowadays, breweries are expanding, taking into account the responsibilities they have over the community, offering job opportunities and inspiring other businesses to approach development and grow economically. In addition, many breweries are moving towards a more environmental-friendly process that, as a consequence, has positive effects in the community, spreading awareness of the importance of taking care of the planet by creating clean processes. Brewery wastewater, as with many food and drink-related wastewaters, can be treated very efficiently using high-rate anaerobic biological processes, such as Veolia biobed technology. The anaerobic process can typically remove up to 85% of the total chemical oxygen demand load from the wastewater and convert it into biogas, which can be used as a renewable energy source to replace fossil fuel in the brewery boilers, or as a fuel source to generate electricity in a combined heat and power plant. Beer is produced by the use of many natural elements, which have residues that can be used for other products, such as the rootlets are commonly used for animal feeding. Hops have the possibility of being used again as fertilizers. Some drugs, vitamins, and food additives use the residual yeast because of the amount of vitamin B that it has. Beer bottles and cans are recycled. Some associations use the same bottles and cardboard carriers in order to reduce their environmental footprint. They invest in new equipment and follow new techniques that involve new ingredients, that they reduce the energy, consumption, and pollution.
The brewing process.
First, We have to peel the grains. In this case, we've considered the Pilsen malt for its flavor, chocolate malt because it gives a darker color and flavor to our beer, and barley because it's the principal source of carbohydrates. These go into a centrifuge peeler to remove their skins and then into a mixer to pulverize the grains. The next step is boiling the wort. The malt sugar solution, called wort, is boiled with hops for 2 hours in order to obtain the bitterness and stability of the beer. Then, the wort is transferred into a whirlpool for the wort separation stage, where any malt or hop particles are removed to leave the liquid that will be cooled and fermented. In the fermentation vessel, yeast is added. In this stage, the temperature must be controlled at 20 degrees Celsius to prevent any bacteria growing and to have a complete reaction. Yeast converts the sugary wort into beer by producing alcohol and carbon dioxide, which is later used in the process to give the beer its sparkle. Then, the wort has now become green beer. The next step is the maturation. After fermentation, the beer previously obtained needs to be mature in order to develop the resting flavors with the help of the yeast. This stage is the longest stage of the process, lasting approximately 2 weeks. Finally, the beer is bottled with a little bit of added sugar to provide the carbonation.
Development of the process. Here we have our process flow diagram, which helps us explain better this brewing process. At stream 1, water enters at standard conditions, 25 degrees Celsius and 1 atmosphere, and is mixed with stream 4. Then, raw materials go into the peeler, and its skins come out. At this point, we have barley and malts that will be pumped and mixed with water from stream 1 up to stream 5. This mix, now called wort, is mixed with hops from stream 7. This new mixture, known as sweet wort, enters a boiler, where the temperature will increase to 100 degrees and remain at 1 atmosphere. At stream 10, the sweet wort is pumped into a whirlpool separator. Malt and hop particles are separated and exit as waste from the whirlpool at 95 degrees Celsius. At stream 12, the wort comes out from a bottle stream at the same temperature, and it is pumped into a cooler to decrease the temperature to 20 degrees Celsius, and then pumped and mixed with the yeast coming from stream 14. The new mixture enters a fermentation tank, where greenhouse gases, mainly carbon dioxide, come out from the fermentation tank at 20 degrees Celsius. This is represented as stream 16. The wort obtained from fermentation at 20 degrees Celsius is pumped and enters to a centrifuge separator, where yeast will be separated. At stream 19, wort is obtained at 10 degrees Celsius, and it is pumped into a maturation tank, where its temperature will be controlled to remain the same. Finally, the product is now beer, which is pumped at this temperature and sent to tanks for packaging and distribution.
It is important to know that for this material balance, we began with 5,000 kg per batch of water and ended up with 3,399.75 kg per batch composed by our final product: water, malts, hops, carbon dioxide, and alcohol.
In order to calculate the energy balance, the next assumptions were made. There were no accumulations, therefore, it's a steady state. Potential and kinetic energy are neglectable. The values for the different unit operations were based from the craft beer production of 2013 document, and then were scaled down to fit the process. All of the energy calculations for unit operations, except for the fermenting vessel, were obtained by this methodology. For example, here are the values of mass flow rate and work done by the pump from the reference document. These calculus were made so as to scale it with the mass flow rate of the process explained before. With this, it is concluded that the work done by the pump is of 0.9484 kilowatts. Therefore, here is the example of how the energy balance was made for the pump. The fermenting vessel was considered as a bioprocess, thus, other specific assumptions were made, such as yeast is neglectable because it acts as a catalyzer. Heat of reaction is the heat of combustion. The difference between a specific heat of reaction and heat of reaction can be ignored. There is no evaporization. For this specific unit operation, heat capacities of compounds entering the fermenter were needed, so as to obtain the enthalpy change. Some of the data was obtained from different resources. Heat of combustion from the reaction were also needed, so as to obtain the final heat around this operation unit. The amount of glucose present in the compounds was obtained in order to have a more precise energy balance. According to the Comisión Federal de Electricidad, the fee for the electricity in November of 2017 to an industry was of 1.594 pesos per kilowatt hour, and for natural gas was of 0.32 pesos per kilowatt hour. Considering that this process requires 18 days to obtain one batch, and with the use of this data and the values obtained from the energy balance, the total cost per batch is. Therefore, assuming that the plant works 365 days per year and 20 batches, the total cost of the brewery process is the following. Conclusions: energy consumptions and greenhouse gases reducing measures. Energy consumption due to machinery fluctuates between 60 and 85% of total consumption of a company. Thus, programmable automation is suggested as a prime tool for achieving energy efficiency. Moreover, trying to isolate the units in which thermal energy is supplied prevents the excessive loss of heat. Maintaining all units well preserved and performing the necessary repairs helps to reduce friction with them and to avoid the blockages in the pipelines. This optimizes the power supplied by the pumps. To gradually invest in more powerful, clean fuels must be one of the perspectives to the future. Hydrogen, for instance, yields 155% more energy than natural gas measured in megajoules per kilogram, due to its combustion, according to the University of Illinois. Clearly, hydrogen production as a relatively noble energy source is expensive, raising the costs of its acquisition. However, it has been suggested that hydrogen can be produced from the splitting of a water molecule using solar energy, and such systems may be implemented in the very facilities of a company, even in homes. Further, if hydrogen is employed as a fuel in the boiler, the products of its combustion are not greenhouse gases. A more efficient fuel may allow this brewing plant to increment its production, reducing its energy consumption costs in the long term, and maximizing revenues, despite the initial investment being significantly larger.